Hey guys, hi, welcome back. So in this video, we will solve the questions of gate and all the questions are of thermodynamics. This is the last part of the previous year solved questions. So let's start with the first question. The first question is which among the following sets of Maxwell relations is correct? You are having four relations here. You have to choose one set which is correct for correct Maxwell relation. Here it is given U is the internal energy, this U. H is the what? Enthalpy. A is the Hellman's free energy, this term, and G is the Gibbs free energy. So for this, to check the four options, you have to see this term. Okay, this factor you have to check. Clear? Here in the first option, you are having U, which is the internal energy. So we will write for the first option. We will see. We know from the first law dq is equals to what? Du plus dw, which can be written as dq is what? Tds equals to du plus dw can be written as pdv. So from here you can write du, the change in the internal energy, it is equals to what? Tds minus pdv. From here what you can write? Temperature T, it is equals to del U by del S at constant volume. And pressure P can be written as minus del U by del V at constant what? Entropy. So here if you see, the first option is what? Del U del V at constant S. But here it is what? Del U del S at constant V. So the first option is what? Incorrect. Now we will see for the second option. Here it is given enthalpy H, and we know H is equals to what? U plus PV. PV. Okay. When you will differentiate, then what you will write? DH is equals to du plus PdV plus VdP. Right. Now you see this du can be written as TdS minus PdV. Alright. So you can write du is equals to what? TdS minus PdV. Rest terms are this plus PdV plus VdP. Now you see this PdV and this PdV will get cancelled, and you will have DH is equals to TdS plus VdP. Right. From here you can write the temperature T is what? Del H by del S at constant pressure, and V is equals to what? Del H by del P at constant entropy. So here you see V is equals to what? Del H by del P at constant entropy. T is what? Del H by del S at constant pressure. So the correct option is option B. So this is how you can check. Just see what is given here. Alright. Next, let's see question number 2. Question number 2 says a Carnot cycle operates on a working substance between two reservoirs at temperature T1 and T2. There is a Carnot cycle which is operating on a working substance between two reservoirs. They are at temperature T1 and T2. Here it is said T1 is greater than T2. That means T1 is the temperature of the source, that is the hot reservoir, and T2 is the temperature of the sink, that is for the cold reservoir. Now you see during each cycle an amount of heat Q1 is extracted from reservoir at T1 and amount of Q2 is delivered in reservoir to T2, which is incorrect. So for this, if you see, this is what? This is the source. Alright, this is the temperature T1. This is the working substance here, and here you are having what? This is the sink. Sink is the temperature T2. Now, how much work is done? W work is done by the working substance by taking Q1 heat, right? And Q2 heat is delivered to the sink. This is what it is said. Now you have to say which one statement is incorrect. So here the first statement is what? Work done in one cycle is Q1 minus Q2. So it is correct because W is equals to what? Q1 minus Q2. It is taking Q1 heat from the hot reservoir, right, from the source, and it is delivering Q2 heat to the reservoir 2 after doing work, right, after doing W amount of work. So W is equals to Q1 minus Q2. This is correct. Next, Q1 by Q2 is equals to T1 by T2. This is also correct. Last two options are what? Entropy of hotter reservoir decreases. This is what is this given. Now, for the hottest reservoir, we will see the entropy is what? So you see, the change in the entropy delta S, it is equals to what? For hotter reservoir, we know delta S is equals to what? dq by T. So here what it is said, in this case, what you will write? For the hotter reservoir, the change in the heat is what? Q1, right? So it is what? Q1. Clear? Divided by what? T divided by T. And it is what? Here you see Q1 is what? Q1 is transferring heat. The heat is what? Q1 heat is transferred. That means what? The reservoir, hot reservoir is what? From that heat is ejected. Means it is transferred, right? So you will write this Q1 to be negative. So here you will see delta S is what? Negative. Yes or no? Next you see it is decreasing, right? It is negative, that means it is decreasing. So option C is also correct. Next what we will see, entropy of universe is increasing. Let's see for option D. Here they said entropy of universe is increasing, which is consisting of the working substance and reservoir, right? So you see here, this is the figure. Here it is said. So we will see the entropy for the working reservoir. Delta S is equals to what we will see. So you see the working substance reservoirs, the working substance entropy change is what? If you, sorry, you will see the entropy of universe. It is consisting of what? The source, the sink, and the working substance. So you see for the source, the entropy is what? Change in the entropy. It was minus Q1 by T1, right? This is what it is there. This is also T1 you can write. Next you see, here again you see, in the sink the heat is what? Transferred, means it is accepting heat. So it will be plus. How much heat change? Q2 heat is there. Temperature is what? T2. Plus for the working substances you see, work done is what? Q1 minus with what? Q2. So the change in heat is what? Q1 by T1 minus Q2 by T2, right? Work done is Q1 minus Q2. From there we have written. So you see here, this is becoming what? 0. All are getting cancelled. That means the change in entropy is equals to 0. But here it is said what? Entropy of universe. It is increasing, but it is not so because delta S is equals to 0. So the correct option is, sorry, the incorrect option is option D. For this question, the correct option is D. But according to the system, the statement which is incorrect, that is option D. Clear? Now let's see. Here it is said, in a first order phase transition, at the transition temperature, specific heat of a system. It is said a first order phase transition is there. Here if to say at the transition temperature, right? What will be the change in the specific heat? All right. So the first option is it is diverging and its entropy remains the same. Second is diverges and its entropy has finite discontinuity, remains unchanged, and its entropy has finite discontinuity, and its entropy changes. Now you see, when we are talking about the first order phase transition, we know that in case of first order phase transition, the specific heat diverges, right? So specific heat is diverging. Clear? So you will see option A is having this condition and option B. So the rest two options are eliminated. Next you see, here it is said entropy remains same. In the other one it is said entropy has finite discontinuity. Now we see in case of first order phase transition, what happens? First order derivative of Gibbs free energy is what? Discontinuous, right? We know first order derivative of Gibbs free energy is discontinuous, right? That means entropy, it is a first order derivative of Gibbs free energy, so entropy is what? Discontinuous. That means it will have what? Finite discontinuity in the first order phase transition. So the correct option is option B, right? This is wrong. Next, let's see the isothermal compressibility kappa of an ideal gas at temperature T0 and V0 is. So you have to directly write what is the isothermal compressibility kappa, right? Isothermal it is said, so the temperature is constant, we already know. Clear? So you will write here the formula for this. We know that the isothermal compressibility is what? Minus 1 by V naught, right? Del V del P, right? Keeping the temperature constant. So this is what it is. And if you don't remember the formula, Just remember, when we are talking about compressibility, then there will be a negative sign. So eliminate the positive eliminate the positive options. Next is what? Isothermal compressibility, right? So isothermal means temperature is constant. In that case, there is no change in what? Temperature. So see the T constant, and here you will have what? Volume will change with respect to what? Pressure. So this is what you will write, minus 1 by V naught del V del P. Something is getting reduced. I have said in this in the lectures also. You can go and check that lectures. There I have written the some important variables I have added, and I have written about the isothermal compressibility. We have discussed about the adiabatic coefficient and all this. Alright. Now let's see the next question, question number 5. Here it is said a classical gas of molecules, each of mass m1, is in the thermal equilibrium. There is a classical gas of molecules. Their mass is what? m1, and they are in thermal equilibrium at absolute temperature T. The velocity components of the molecules along the Cartesian axis are Vx, Vy, and Vz. These are the velocity components. You have to find the mean value of Vx, Vy. So it is directly that just you have to find the mean value of this particular term. So mean value is written as this Vx plus Vy whole square, its mean value. So it's a directly you can do the a plus b whole square formula. It will be what? Vx square plus Vy square plus twice. I'm writing individually this Vx Vy. So we already know this is what? 0. This is 0. So this entire term will be what? 0. And here you will have what? Vx square. So we know the value of what? Vx square is what? Kb T by m. Right? Plus it is what? Kb T by m. So it will be what? 2 kb T by m. This is the answer. So the correct option is what? Option D. So directly you can do. Just you have to write the average, and then what you have to do? Average or mean value both means same thing, and just write the formula. So now let's say question number 6. What is said here? The internal energy U of a system is it is given by U equals to lambda V to the power minus 2 by 3 S square. This is the internal energy. Lambda, it is a constant of appropriate dimension. V and S, these are the volume and entropy. So you have to find which of the following is the correct equation of state for the system. You are having 4 equation of state. You have to choose the correct equation of state for the given system, which is having internal energy this. So you are having what? Internal energy given to you. U is equals to what? Lambda x square V to the power minus 2 by 3. So I'm writing it in the denominator. So you see, you will write the first law dq is equals to what? Du plus pdv. Okay, that is dw. So you see, from here you can write du is equals to what? dq can be written as tds minus pdv. All right. So from here you can see temperature T will be equals to what? It is del U by del S at constant V. And you can write P is equals to minus del U by del V at constant what? At constant entropy. So here if you find T will be equals to what? Del U by del V. So you del U by del S. So you see lambda V to the power 2 by 3 is constant, and this will give you what? 2S. So I'm writing it in this way. Next you see, you will write the pressure. P is equals to what? Minus sign del U del V, right? So lambda S square is constant. V to the power minus 2 by V to the power minus 2 by 3 on differentiation will give you minus 2 by 3 into with V to the power minus 5 by 3. You can see this one. 2 by 3 minus 1 will be 5 by 3. Alright. So here you can see minus a will become plus. 2 by 3 lambda is as it is. V to the power minus 5 by 3, I'm writing it in the denominator, so it will become plus 5 by 3. Now this S square we will substitute from here. S will be equals to what from this equation? It is V to the power 2 by 3 T divided by twice of lambda. Right? Sorry. Yeah, this is twice of lambda. This is how you can write. So from here what you can write? This will give you what? Twice of lambda is there. This is what it is. So you will do what? In this particular case, you will write here, this is T square, this is 4 lambda square, right? 2 square, and V to the power 2 by 3 is what? V to the power 4 by 3. Clear? So these two will cancel this 2. 2 2s are 4. Lambda and lambda will get cancelled. So P will be equals to what? Numerator T square, 2 3s are 6, right? Lambda is there, and this one will give you what? V to the power 4 by 3 minus 5 by 3. It is v to the power minus 1 by 3, right? So you will get here v to the power 1 by 3. So you can write this term as p v to the power 1 by 3, taking this term to the left hand side and bringing this t square also to the left hand side, which is divided by what? T square. Yes or no? This is how you can write. And you will see 1 by 6 lambda. This is what? Constant term. Yes or no? So from here you will see the equation of state is what? This is the equation of state. That is option A is the correct option. Clear? Now let's see the next question. Here it is said, as shown in figure, an ideal gas it is confined to chamber A of an insulated container. Insulated container means what? There will be no exchange of heat from outside. So there is an ideal gas which is confined in the chamber A. This is chamber A, this is chamber B, right? You see, here it is said chamber B is what? Vacuum. This is vacuum. This is filled with ideal gas. Clear? Ideal gas means what? There will be no interaction of particles, because in ideal gas, particles are not interacting with each other. Now you see, when the plug in the wall separating the chambers A and B is removed, means this particular plug is removed, the gas fills both the chambers, right? Means the ideal gas, the molecules will what? From here they will move to the other side. So you have to see out of which these four statements, which statement is correct. So here you see the first statement is that the temperature of gas remains unchanged. Second is internal energy decreases. Fourth is temperature decreases as it expands to fill space in B. Fourth is internal energy of gas increases as its atoms have more space to move. So first of all, you see ideal gas is there, so the particles will not interact with each other, right? If you use the first law, dq it is equals to what? Du plus dw. Since the particles are not interacting with each other because it is what? Ideal gas. So work done will be what? Zero, right? So this is zero. Also it is said that it is what? It is an insulated system, right? For insulated system, what we know? That dq will be what? Zero. Yes or no? dq is zero because there is no change in heat. So from here you will get du is equals to what? Zero. Du is equals to zero means what? Internal energy is zero. And we know the internal energy is a function of what? Temperature, right? So the temperature will be what? Zero. Means temperature is not changing. Clear? So you can write the temperature of gas remains unchanged. Now let's see question number 8. What is said here? A small disk is suspended by a fiber such that it is free to rotate about the fiber axis. Alright? It is suspended about a fiber. It is free to rotate about the fiber axis. A small disk is there. Now you see it is shown in the figure here. The Hamiltonian is given here for small deflections. I it is the moment of inertia. Alpha it is the restoring force. Now you see restoring torque per unit deflection. The disk is subjected to angular deflection theta due to thermal collisions from the surrounding gas at temperature T. Here P theta it is the momentum conjugate to theta. The average and RMS angular deflection, that is theta average and theta RMS is what? So here the theory part you don't have to study this so much. You can read it on your own. Here the Hamiltonian is given to you. I and alpha, these are I is the moment of inertia, alpha is the restoring force, P theta is the momentum conjugate to theta. So here you find the average and RMS angular deflection, that is theta average and theta RMS. Now you see in this case what will happen? This disk will oscillate, right? Oscillation means what? It will move when it will oscillate from the mean position, the distance that it will traverse in the left hand side, that much only it will travel in the right hand side, right? So theta average will be what? It will be equals to zero. From the mean position it will cover equal distance in opposite directions. All right, now you have to calculate theta RMS. Yes or no? This is what you have to calculate. So in this type of questions, theta RMS is calculated by using the law of equipartition of energy, and we know that with each quadratic term how much energy is associated? kBT by 2. So here if you see, this is half alpha, right? And this is what? Theta RMS square. So it is equals to what? Energy associated with it is this half kBT. So half and half will get cancelled, right? So theta RMS it is equals to kBT by alpha. So this is a square here. So theta RMS it will be equals to what? This will become root over kBt by alpha. Clear? This is what root over kBt by alpha. Theta average is equals to 0. Clear? So the correct option is what? Option B. Is it correct? It is theta average is equals to 0. Theta Rms is kBt by alpha. So it is correct. Next, let's see question number 9. Which of the following is an example of first order phase transition? So I had done the last lecture on phase transition. If you see that, then directly you can say the first is a liquid gas phase transition at the critical point. No, this is not a first order phase transition. Second is a paramagnetic to ferromagnetic phase transition. So we know this is a second order phase transition, right? Next, what we are having, a normal metal to superconductor phase transition. This is also second order. A liquid gas phase transition away from the critical point. Yes, you remember liquid phase transition at the critical point is not the first order phase transition. Away from the critical point, it's the phase transition. Also, I've said that first order phase transition is away from the critical point. So the correct option is option D. Now let's see question number 10. Here it is said, consider a triatomic molecule of shapes shown in the figure in 3 dimensions. This is a triatomic molecule in 3 dimensions. You have to find the heat capacity of this molecule at high temperature. And it is said the temperature is high, much more than the vibrational and the rotational energy scales, but it is lower than the dissociation energy. That means it is not that high that the bond will break. This is what it means. So directly we will find first the degree of freedom, right? From that we will get the energy U, and then we will calculate the heat capacity, because heat capacity is what? Del U by del T. So first the degree of freedom will be equals to what? You see here the degree of freedom is what? 3 translational, 3 rotational. Higher temperature, so the vibrational degree of freedom will also come. It is 3, right? And you know that the vibrational is calculated in 2 modes, kinetic and potential, right? We are not going into the details. So total degree of freedom is 9. Now we know that the energy associated with translational and rotational degree of freedom is what? Half kBt. And with vibrational it is what? Only kBt. Okay, so you can write U, the energy is equals to what? 6 into with half kBt plus 3 into with kBt. So this is 2 3s are. So finally you got here what? It is 3 plus 3. This is 3 plus 3, 6 kBt. This is the internal energy. Okay. Now the heat capacity is equals to what? Heat capacity is equals to del U by del T. Right, del U by del T. So it is equals to what? 6 kb. So the correct option is option D. So the answers are quite simple. The only thing is that you have to see what are the terms given to you, triatomic. Then you have to calculate that heat capacity, how it is related, how you can find. Just see the formula of heat capacity is del U by del T. That means you need to know the U. How you will know the U? By the use of degree of freedom. So this is how you can see. So that's all in this video. I would request you do all the sums on your own. That will help you more. Thank you so much. Have a good day.